Alright, we're going to go through again with our multimodal look at least, just to talk about first and then solve a basic cable problem. And the basic cable problem you do in a training program for a couple of reasons, mostly because this shape here gives you the shape of the moment curve on a load. It's something called a funicular structure. And so what I've got here is something spanning 200 feet. It's a cable 74.225 feet to the right. There is 300 pounds hanging down. There's also, I'm going to go here, I'm going to go ahead, edit, copy, and then edit, paste. And I'm going to paste another force over here. And I can go ahead and never do it this way. We're just going to go ahead and we're going to call that 100 pounds. Right, so in other words, that's not 300 pounds. And if I go here to view, toolbars, large tool set, which you will not see, I can go ahead and I'm just going to put a piece of text down there, up to there, so we see that that is 100 pounds. Now, how can I just do that? Well, on these problems, all you can determine is one point. The rest of these, you know where they are up and down. In this case, this is 147.923 from the left support, but you cannot determine where they are up and down. You know where they are left and right. You do the rest by basic trigonometry and basic graphics. And the way you solve then this problem is this. I'm going to sketch it now on the right. Within a sketch over here. The way you generally solve that problem then is this. You know two supports and they have reactions, right? And I'm going to go ahead and show this positive even though I know it's negative, right? And this is the one problem that you probably do just basically show the reaction coming the other way. All right, so you have the reaction at A, and they have the reaction at B. Of course, it has two components. And because of the geometry, you're going to know eventually what is the geometry of that, because it's the opposite of this cable here. But what you do first is you want to solve for the reactions, as always. Solve for the reactions. Now, the way this can be done, you can solve for the reactions in the y, but you cannot solve for the reactions in the x. In other words, what we call the horizontal component. We cannot solve for it because the moment equation, when you write it along any point here, those forces are concurrent and they fall out of the equation. But what you can do, looking back over here, is you can think about force times orthogonal distance, force times orthogonal distance, and force times orthogonal distance. And in that case, you cannot do R cross F on this force because you don't know where it is. But you do know its orthogonal distance. So you end up solving for reaction. I'll solve for reaction at B. By summing the moments about A. And I do that. If this is 300 and this is 100, I say the sum of the moments about A is equal to 0. And they're equal to then 300 pounds times a distance of 74.23 feet. And of course, thumbs into the board, so that's a negative. And then plus 100 pounds times a distance of 147.923, or 0.92, 147.92, and that is negative. And then plus the reaction at B in the Y times the full 200 feet. And you get, when you do that, you get a reaction at B in the Y equal to, and we'll do the calculator punch, that we won't do it very often. We're going to turn on the calculator here with this, hit the clear here, and we have 300 times 74.23, and that's a negative, right? We want to remember that. I'm going to go ahead and store that into alpha A, and remember it's a negative. And I'm going to take 100, or if I'm better than that, I'll say minus 100, minus 100, minus 100 times 147.92, 147.92 feet. These are torques, of course. And I'm going to add that, of course, to alpha A. And I'm then going to divide by I want to subtract. So I want to make sure I add those together. So what I have is alpha A plus 14,792. That's my total negative moment. I divide it by 200, and I get the reaction of 185.30. Now, a cable problem is another one of these problems that you, in the end, have to realize that this problem on the left, ooh, nice, you can pull that smaller and larger. You can look at this problem here and you can realize that, yeah, there's more force. The 300 is here and the 100 here. You're going to have more reaction over on this side. No different than if you had just taken these things right across the beam here. So you go about and do that on the left side, and then you go about and do it on the right side. I'm going to skip the reaction here at this point. Of course, you just do the reverse, right? Except instead of this, instead of 174, it is 200 minus 74, and this is 200 minus, because you're going about the right side, and you'll end up with the reaction at B at A in the Y, and I will have you do that. I'm not going to do that here, is equal to 214.70, because these, of course, have to add up to 400. Now, how did we do that? Well, sum of the moments about B is equal to 300 times this distance, and it's positive, plus 100 times this distance, and that's a positive because it's sitting with your thumb out of the board, plus the reaction times 200, and that would be negative, and so you end up with that value there. So you solve first for the vertical reactions. Very often in other types of problems, in this problem we have ignored the force of the cable. Now if there was a weight to the cable, generally it would add up relatively equally, because the cable, even though you've got different lengths here, it's going to generally add up equally to both sides. That's what you do when you have a uniform load problem, that you know that at any point on either side on an equal elevation problem that the weights are generally going to be split. That's not going to be the case in a problem when you have two different elevation cables. So the first step in all problems, even if you don't need them in this one, you definitely need it, is to solve for the reactions. And cables are one that you kind of have to do force times orthogonal distance, because you do not know. There is only one spot you know right there where you know the geometry, and that's what's going to play out in a second when you try to determine the forces in the cable. All right. Thanks for listening. We'll continue in a second.